Hello guys, this is Cruncher Jean. Today I'm going to do a quick video about causal discovery and the last crunch on the platform, the ADIA Lab crunch. The goal is to show you how to turn the 12,000 datasets into one dataset, unify everything together. It's a feature embed. It's very easy. I think I'm going to cover it in less than 10 minutes. But the goal is also to do a bit more content around what's on the platform, try to help you guys in going through and finding the best solution. So this is a very good solution. It can help you raise your score a lot. You probably notified that I have better microphone now. Its goal is to make better video and make more content, guys. So I hope you enjoy it. Let us know in the comments. So today, how to turn the ADIA Lab dataset into one supervised learning dataset, right? This is what we want. This is what we are used to. We're used to one dataset, the features and the label. We need an index, right? A clear index. And we want everything in the same data frame. We don't want to have to loop over all the datasets and etc. That's not practical. It's going to be hard to use with the ML libraries and etc. So first, let's step back. What are we trying to do in this crunch? I think it's important to talk about it just briefly. In the 12,000 datasets that you have when you load the CLI and when you get the datasets, you have two parts in this dataset. First part is the train dataset, 12,000 train. Each train is composed of X, Y, and some features, right? They all have the same number of observation, 1,000, but they have a different number of features. And you have a Y train. The Y train is basically the transcription of the causal graph. What's a causal graph is a representation, a graphic representation of a causal system. So in this slide, for example, X causes Y, okay? And it's just a way to represent the causality, represent a causal system graphically. I think it's nice. It really gives you an idea of what's happening. The issue is that we have 12,000 of that, right? And so all this system needs to end up in one and unique data frame. And what we try to do for each of these systems is we try to understand not what X or Y are doing, because we know in all this data set, X is causing Y, right? So the bottle is getting on the floor is wet. It's raining outside, the floor is wet. There is many reasons for that, but it's always X causes Y, and then we have a series of features here, 0, 1, and 2, and your job, the job of your algorithm, is to find in which class this feature is belonging to. So either it's a co-founder, it's a collider, it's a mediator, it's an independent feature, it's a causes of X, consequence of X, causes of Y, consequence of Y. And I forgot causes of Y. No, I said it. There is 8. Anyway, dig a bit online. There is a lot of content about it. I don't want to spend some time on this today, but the only thing you have to remember is that there is 8 variables and you need to find the right class for each of the 12,000 datasets, right? And the label is basically this agency matrix that is an encoding of that relationship. So the encoding is quite straightforward. So let's look at it. Here, who is parent of who? So when we say parent is who, when you see an arrow going from 1 to X, it means that 1 is a parent of X, right? 1 causes X. So 0 is a parent of nobody. The feature 1 is parent of feature of Y, means that they're going to be an arrow between 1 and Y, going from 1 to Y. So in my slide, it's under here. Yeah, it's here. 1 to Y. Then if you look at the feature 2, you see that feature 2 is a parent of 0 and is a parent of Y. So feature 2, you're here. There is an arrow to 0, so you causes 0 and you causes Y. So this is what you try to do. There is a code snippet in the quick starter that I'm going to share with the video that give you this straight out of the box data frame that just read basically these matrices and give you who is what. So you don't have to do it. This part is already covered. So when we look at each data set, what we have actually is this is our X, right? And this is our label. This is our Y. This adjacency matrix, it's our Y. This is what we're going to have in the Y column, and that's going to help us basically for the labeling. But first, let's start with the features. So what we want, what we are used to is an index and some features. What we're going to have to figure out is what feature can we build such that we don't have 1,000 rows, but we can transform this data into just one row per variable, right? And it's easy, just be imaginative here. There is one very easy feature we can have is the covariance. So we can look at the covariance between 0 and X. We can look at the covariance between 0 and Y. But also the covariance between 1 and X, the covariance between 2 and X, the covariance between 2 and Y. And so here you will have for the dataset 0, variable 0, what's the covariance between 0 and X, what's the covariance between 0 and Y, what's the covariance between 2 and X, what's the covariance between 2 and Y, etc., etc. You can think about other features. It could be the maximum correlation between this feature and all the other features. It could be the minimum covariance of these features. It could be the average covariance. It could be the standard deviation of that covariance. It could be just the correlation. It could be mutual information, polynomial features. Here, it's really a matter of how imaginative you can be. There is really an infinity of features you can build here. And I think, guys, really, that's really important. There is hundreds and hundreds of possibility here. And the larger your data frame is going to be, the more information, the more chance you get to grab some information that was not basically represented here. Creating a feature, this is feature embedding. This is actually where this challenge kind of lies if you wanna use a supervised learning technique. So bear with me. We are now going to look at how to build the label. This is completely straightforward because we have the agency matrix for each of these data sets. So we just have to run the script in the quick starter and get who is what in the system. So variable 0 is the consequences of Y. Variable 2 is an independent feature. You can see here. Variable 3 is the causes of Y, etc., etc. So once we can do it for one data set, it's just trivial. We just go through all the data set, run a loop, and build the data frame for each of these data set. After the loop or in the loop, just concat everything together, the magic concat, and you end up with that data frame. And we can see here, we have the index of the dataset 1, dataset 2, dataset 3. We have the variable 0, 1, 2, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, and the feature that we built plus our label. So this is exactly what we wanted. We are in the sweet spot, and we can just throw a random classifier at that, right? If you do it, you actually get a pretty decent score with 40% accuracy, which would probably put you in a very comfortable situation in the leaderboard at the moment of that video. But the more variable you will be able to create here, right? Be creative. The more relationship you manage to figure out, I think the better your supervised learning is going to be. So that's it. I have a quick starter as well that I'm going to share. And I think I'm going to go through the quick starter in a video or maybe in a live stream. So we go through it together. If you have questions, we make sure that everyone goes and go through it. All right, guys, thank you so much. I hope it helps. Bye.